This pattern can be useful when you want to represent part-whole hierarchies of objects. In other words, when you want to represent a tree-like object structure. It's also something worth considering when you want clients to be able to ignore the difference between compositions of objects and individual objects. As we've noticed in the example, as far as the client is concerned, it doesn't matter if the operation, getSize in our example, is called on a leaf or a composite. Let's have a look at the pattern consequences. As every pattern, this pattern too has a few consequences. First of all, it makes the clients simple, as clients don't know whether they're dealing with a leaf or a composite component. It's also easy to add new kinds of components. That's because newly defined subclasses automatically work with existing structures and client code. So clients don't have to be changed for new component classes. Imagine you'd have another type of file system item. You could simply implement it and work with it. The client doesn't care, it simply calls getSize on the file system item base type, not on the subclass type. This is the open-closed principle from the solid coding principles at work. A disadvantage is that it can make the overall system too generic. By making it easy to add and remove items to the composite, we also make it a bit harder to restrict the components of a composite. It's no longer the compiler that checks for this, as add and remove accept the abstract base type and not the subclass. Take our file system item example. If we want to restrict the directory component to only contain files and not subdirectories, we cannot rely on the compiler for that, as add and remove accept the base file system item. We have to write additional code to check for the actual type at runtime. That's it for the main consequences. Let's have a look at the related patterns. There's quite a few related patterns to this one. From the behavioral pattern family, there's the chain of responsibility. The component parent link is often used for that. When a leaf component gets a request, it can potentially pass it through the chain of all parent components down to the root of the object tree. It's also related to the iterator because an iterator can be used to traverse composites. Lastly, the visitor pattern can localize operations and behavior that would otherwise be distributed across composite and leaf classes. You can thus use it to execute an operation over the full composite tree. Time for the module summary. The composite pattern provides a transparent, easy way to work with tree-like structures. Whether the client is interacting with a leaf or a composite isn't of importance for the client. The recursiveness of the operation makes sure of that. Up next, we'll learn about the facade pattern.